Hi, my name is Dr. Ren. I'm going to be teaching the AP Calculus AV and BC exam prep. In this class, we're going to review concepts for AP Calculus first AV. After that, we're going to move on to BC. A little bit about me. I have a PhD in curriculum and instruction with a minor in mathematics from New Mexico State University. I have two masters, one in education and the other one, well, specifically in math ed, and the other one is in pure mathematics. My undergrad is in applied mathematics, so I start pretty much being interested in education once I was teaching to college students while I was doing my master's in pure math. I was teaching at the math department in NMSU for 3 years. After that, I moved to the education department teaching pre-service teachers mathematics. This is going to be my 10th year teaching high school. I have taught pretty much every single high school class from geometry up to multivariable calculus. Currently I'm working at Dulles High School. I'm the AP Calculus BC and the multivariable calculus teacher, so that's what I teach over there. Before being at Dulles, I was at George Ranch High School. When I arrived to that school, the passing rate, it was 16%, and I moved it to 97% back in the day, and I think 2016, 15, 16. Most of my students belong to the Math and Science Academy at Dulles High School. I have a lot of multivariable students. I teach 4 classes of BC, so I really do calculus all day. So I really enjoy teaching both calculus and multivariable calculus. I enjoy when students have the aha moments and they understand challenging concepts in mathematics. Yeah, that's what I enjoy every day, obviously, and that's why I'm a teacher, because I enjoy when students learn math. And I enjoy mathematics, so the combination of being a math teacher, it's perfect for me. I enjoy answering questions. I love when when students, they have really creative questions. I really enjoy that. And they also challenge me to be better every day. So that's for that. Also, if you have any questions at any time, feel free to ask me whatever question you have, and that's perfect, okay? The course is going to be pretty much from February 4th to April 7th. All those weeks is going to be the content of Calculus AV. We can go over free response questions that are published in the College Board website, and also we're going over some handouts that are very helpful for reviewing. We'll go to each concept fairly quickly, but if the students have any questions, they can bring the questions and we can go over whatever questions they have. The prerequisite for the prep is pretty much currently that the student is taking either Calculus AV or BC. It's going to be fully online. We're going to meet Sundays from 3:30 to 5:30 Central Time. There's not going to be class on March 10th because that's when I have my spring break, and then March 31st. After April 7th, pretty much we're going to have like a month where we are covering the BC part of the exam, which is from integration techniques, parametric equations, vectors, polar equations, and obviously series, sequences, Taylor polynomials, Taylor series, Lagrange error bound, and alternating series test, and all that stuff, all the tests for convergence and divergence. So that's going to be the last month. Like at the beginning, we're going to start with limits, and then the last topic that we'll cover before we become like the BC prep is going to be solids of revolution, and arc length is going to be part of BC. So that's basically after April 7th. The idea is that the students get ready for the AP Calculus exam. Remember that AP Calculus AV is the equivalent of Calculus 1, and AP Calculus BC is Calc 1 and Calc 2 in one AP test. The idea is that students, they ask questions, review, and they feel at the end of taking this class comfortable taking the AP exam, with obviously the idea that they will be successful in the AP exam. There's going to be like a handout every week with some concepts that students are going to see. I'll go over the handout. Also, students can bring questions from the homework. Students will have weekly homework, and it will be assigned in the Canvas course. It will take between 45 and 90 minutes to complete. The idea of students and parents, they have the question how AP Calculus AB is different from BC. So the idea is that AB, it's slower paced, and pretty much is equivalent to the first semester Calculus 1, and BC is faster paced because it's going to be the same speed as a university level course, because it has Calculus 1 the first semester and Calculus 2 the second semester. All topics in the first 8 units of Calculus AB are also part of the BC curriculum. So that's why we're doing first those 8 units that College Board divides this in 10 units. So the first 8 are going to be the AB, and then 10 are going to be the part of BC, which is very rich. The BC part is, even though College Board only puts 2 units, those 2 units are very important and very fundamental for the next course, which would be, in this case, Calculus 3, right? The score distributions from 2023 of both AP Calculus BC and AP Calculus AB are the following, the ones that you can see there. Most students in Calculus BC, they get 5s. 43.5% of the students, they get 5s. Most of the students, they have a successful AP experience, having 78.5% of the students, they get 3 or above. Depending on the university, most universities accept 5s. Some universities accept 5s and 4s, and only a few accept 3s. Some universities, they do. It depends on each university and the the administration of each university. On the other hand, Calculus AB, around 58% of the students that take the AP test, they have a 3 or above. 22.4% of AB students, they have a 5, 16.24, 19.43. I'm a grader of the AP test, so every year I go, yes, College Board sends me to Kansas City to grade the exams. Some of the questions are basically the same for AB and BC. Actually, 4 of the response questions of both exams are the same. And then 2 of the AB questions, BC will not have them because those are going to be the series questions of BC. And in the calculator portion, the vector parametric equation or polar equation question will be there. It's 3 and 3, okay? So they share 3. Usually it's question number 1, question number 3 and 4 are the same. And then question number 2 is different. Question number 5 and 6 are different. So you can have an idea of how similar is the content of one and another. Also in the multiple choice, around 60% of the multiple choice questions are the same in both AB and BC, of course, assuming that the students are taking the same exam, the one that it's taking in general in the US, because there are several versions of the AP test. But in general, the one that everybody takes on, in this case, May 13 is going to be ideally the same, at least if the student is in the US. If the student is in another country, then they will take another version of the AP test still at the same time. And I have also graded the international version and the secure question of that test. This is how the exam divided. The first part is going to be the multiple choice. So the multiple choice, it has 45 questions. The first 30 questions, okay, which is the first hour. The calculator is not permitted, okay, and there's going to be 30 questions. The second part of those 45 questions is going to be 15 questions with the calculator, and that's going to be 45 minutes with the graphing calculator. The questions here include algebraic, exponential, logarithmic, trigonometric, and in general, most of the transcendental functions that students cover in either Algebra 2 or Precalculus. Questions include analytical, graphical, and tabular verbal type of representations, conceptual representations. Especially in Part B, the questions are very conceptual. I really enjoy those. Most of Part B, you don't require the calculator to solve those questions. Maybe it's required 3 or 4. Of course, it makes easier the situation if you have the calculator for B, right, for the Part B. The second question of the exam, that it's another hour and a half. It's 6 questions. Part A is going to be 2 free response questions. Both free response questions are going to be with calculator. They are going to give the students 30 minutes, either for AB or BC. It's exactly the same format. As I was telling you, from Part A, number 1 is going to be the same question for AB and BC. Number 2 is going to be different. Part B, it has 4 questions. The first 2 questions are going to be the same for BC and AB, but the last 2 are going to be different. Students are going to have 60 minutes to solve the free response with no calculator. And usually the questions are pretty predictable there. It's going to be a fundamental theorem of calculus question. The second one, it's going to be a mix of slope fields or some kind of logistic growth situation there that requires maybe L'Hopital. Usually the last years they have like L'Hopital for question number 4 or 3. They change the number for those, but usually they are, one is the fundamental theorem of calculus and the other one requires chain rule and taking derivatives in general. In the last part, question might include real world context scenarios. If you see the last year test, the milk problem is a logistic growth scenario. So it's pretty interesting. They are really good questions, the ones that they put there, and they actually assess students pretty fairly. And you can see all the tests, the old test, if you Google AP Calculus, either AB or BC, and all free response questions, you can see a bunch of all exams there. We're going to spend a lot of time solving this type of free response questions, and you're going to see that they are very doable. Actually, I think the questions are, when you break them down, they are pretty straightforward. And hopefully the idea is that this class helps students to feel comfortable answering those questions. So the specific topics that both AB and BC share are limits and continuity, that it's going to be, it's basic for any calculus class. I put there the unit and the description of the limits and continuity. The second unit is going to be differentiation, pretty much the definition, the formal definition of derivative, all the rules to find the derivative and the concept, how to tie down the concept of continuity and differentiation at the same time, that to understand how to take derivatives and the idea of the tangent line, right? And the application of differentiation rules, kind of like the chain rule, the power rule, and the quotient rule. Unit 3 is more differentiation, talking about the chain rule, composite functions, implicit derivatives, and inverse functions. That it's a little bit more tricky, but pretty doable. Chain rule, differentiation of inverse functions, and higher order derivatives. Okay, generalize that. Unit 4 is pretty much more differentiation, but it's applying all the concepts of differentiation. Once students, they feel comfortable with the rules, they can understand pretty much all the concepts and apply them into the first derivative test, verbal representation of differentiation. In general, connect that into motion problems and other real life situations. After that, in the applications, we're going over related rate problems, analyzing local linearity and approximations, okay? And one concept that lately has been very important in the AP test, and it never fails to appear in the free response, is L'Hopital's rule. Sometimes College Board requires specific grading ways of the L'Hopital's rule that sometimes in universities they don't do. So we'll go over that so students, they don't lose any points just for notation, because they are very picky with the notation in the L'Hopital's lately. So we'll go over that whenever we go over L'Hopital's. Then we have Unit 5, which is more analytical applications of differentiation, where the mean value theorem and the extreme value theorem are part of it, which are very, very important. And that's going to be usually in a free response question, either number 3 or number 4. More derivatives and more properties of derivatives and functions, how to use the first derivative test, the second derivative test, sketching graph, the candidates test, which is the extreme value theorem, concavity, and how to solve optimization problems and behaviors of implicit relations. Also for calculus, both AB and BC. Unit 6, which is the integration and accumulation of change, will be part of it, which is pretty much tie all the definitions of differentiation with the fundamental theorem of calculus. What else? Properties of integrals, the basic properties of integrals, the connection between the geometry formulas and integration. Pretty much that's what you cover in the first semester of a school year. And then you start with differential equations either in December or the following semester. For me, in this case, I started Unit 8 in January, so I go over Unit 7 before the winter break. Differential equations is pretty much slope fields, separation of variables, sketch slope fields as well. For BC, it would be Euler's method there, but we will learn that after, because we're separating AB and BC, right? So Unit 8 is going to be applications of integration, which is finding the average value of a function via the integral, modeling particle motion problems, solving accumulation problems, finding the area between the curves, and we would close Unit 8 with volumes of using cross sections and also using the disk/washer method, and that would be the end for Unit 8. In Unit 8 for BC, there's more stuff as well as for Unit 7. So when we start the BC part, there's additional topics, as I was telling you. In Unit 6, there's more integration techniques, which is very, very heavy in BC, kind of like partial fraction decomposition, integration by parts, and things like that, okay? So Unit 7 also has, as I was telling you, Euler's method, which is very important. Unit 8, it would have the arc length, the distance traveled along the smooth curve. We will go over the formula, how to develop the formula, and how to use it, of course. Unit 9 is super important. It's the parametric equations, polar coordinates, and vector value functions. That basically that one, it would be how to find the derivatives of parametric functions, determining the position of a particle moving in a plane, if it's moving to the right, to the left, calculating velocity, speed, and acceleration, calculating obviously the derivative and the tangent line using polar coordinates. We would go over finding the area of regions bounded by polar curves, okay, only using a single integral. For Unit 10, which is huge for BC, it would be applying limits to understand the convergence and divergence of infinite series. We would go over the different types of series like geometric, harmonic, P-series, and then we would go over the test for divergence and several tests for convergence, kind of like the ratio test and tests of that kind. We would close Unit 10 with the approximation of sums of convergent infinite series, the error bounds, either the alternating error bound or the Lagrange error bound, and then we would close with polynomial Taylor polynomials, and then also with Taylor series and Maclaurin series, to see where they converge and diverge, and finding the interval of convergence of those. So that's pretty much, this slide is pretty much only BC. That's the part that it's only BC. I don't know if you have any questions. Yeah, just let me know if you have any questions or concerns. What else? We're going to be using, obviously, Zoom as today, exactly the same thing. Where we're going to be posting the handouts and everything is going to be in Canvas. In Canvas, you're going to find pretty much everything: the video, the handout, the key, And also there's going to be, it's kind of like a link. So you can go over the textbook. You can join there to join the class live. Zoom is going to be used for every single class every Sunday. Canvas is pretty much to share material. I share my formula sheet there so you can see it. Once you are enrolled to the course, you'll receive the Canvas invite. The student will receive the Canvas invite 4 or 5 days before the start date. So you would receiving this invite maybe, I think Tuesday or Wednesday of next week. So the Canvas course is going to look like this. We have a screenshot here so you can feel familiar with the Canvas, basically arrangement of the course. For example, if we have that week 1, you are going to see limits. You are going to see the handout. You are going to see week 1, the handout with the PDF. Week 1, if there's another handout like here that it says trigger information to know, you're going to have those two. You can print them or work them in your computer or iPad, and then in Canvas you can click on the homework, and basically you can submit the homework because you'll have access to the Larson 10th edition textbook. So you can send the homework there and it will be automatically graded, so you know if you have it correct or not. The class materials, including handouts, homework, and recordings, will be available for 3 months, okay, after the end of the class. So you can rewatch it before the AP test. Let's say that a concept, it was iffy for you, you can always review it, you can review the video. And if you have questions the following Sunday, we can go over it, whatever, right? So feel free to ask questions. What else? The Canvas invite links are going to be sent typically to the student or the email of the students, again, 4 or 5 days prior to the start date. That's what you're going to see. And you can see that the Canvas is going to be divided like that: home, discussion, grades, pages, files, syllabus. So basically in the modules section is where you're going to find everything, and it's going to be divided by week. So you know, you can see the handout, the homework, and the recording will be published there as well. Usually the recording is published the day after or 2 days after the class. So if you were absent, or if you arrived late, or if you left early because you have something else to do, don't worry, you can always review the video over there. So a sample question that you have over here of a free response, this is from the 2023 exam last year. So you can see that this is what I call a fundamental theorem of calculus question, okay, because it has a mix of the use of fundamental theorem of calculus somehow, and in this case, as you can see, it connects everything together, right? Unit 3, 4, and 2. So it asks about the minimum, maximum. It asks about the open intervals, and you can see that you need to explain. So we'll go over how to explain accurately so the students can get full score in each question, because sometimes students, they lose points because the notation was not correct, or they call the function it, and things like that. Okay, the good thing is that I'm a grader for the AP test for college, therefore I can tell you the details where students usually they lose points because of details. Okay, C, as you can see, that question is screaming L'Hopital rule, so it's very nice. And then D, it's a candidate's test question. It's a candidate's test question there, or extreme value theorem, however you want to call it. So we'll go over questions like this that are very rich. Student, this type of questions, let me go back. The student will have 15 minutes to solve a question like this. Here you can see the distribution of how they score and how many points each part has. One question in the AP test like this one has 9 points. Each of the questions, they are divided equally. They have 9 points. And the students, the maximum score, the perfect score, what they call the perfect score, is a 108. To have a perfect score, student needs to have all the free response perfect, and obviously the multiple choice. So you can see that in part A, it's only 1 point, okay, because it's a more basic question about the minimum and maximum, okay? They need to give a good explanation there. For part B, you can see that they need to have a reason and the intervals. Usually what they do with this type of questions in B, if the student doesn't have the intervals correct, they automatically lose the second point. For part C, as you can see, this one is more rich because it's a L'Hopital's rule. So as you can see, they are very picky in how to explain the indeterminate form 0 over 0 of L'Hopital's. And if you don't put and explain all the P's, you're going to lose maybe a point or two. As you can see, mainly in this question last year, students lost point at the first point. Because sometimes students did not separate the top, the numerator, and the denominator as different functions, and they didn't show to the reader that it was equal to 0. So we'll go over this type of detail so students know how to write it so they can receive full score in this type of questions. Because most students last year, they have the second point and the third point, but they didn't have the first one. We'll go over everything. Especially, I know that most students, they understand the topics. We are going to polish all of this so they can be super confident, and who knows, maybe they get a perfect score, right? So part D, as you can see, is an extreme value theorem. You can see over there the table with all the candidates and how they substitute those as the x's in the original function and the values as f of x, and how to find the absolute minimum in this case and how to justify the answer here. We'll go over everything. As you can see, part D is heavier. It was 3. So you can see that A, even though they have A, B, C, D, they are not equally distributed because D and C, they require more justification and more work from the students. So we'll go over questions like this. So I don't know if you have any questions, please, about the exam, about the AP. I don't know if you have any questions about the format, whatever questions you have, let me know. I'll give you 1 minute so you can think about any question that you have, and then I can show you a sample of how I teach, okay? So let me know if you have any questions. Go back here. Please remember that the Momentum Learning website is that one, and if you have questions, concerns, or something, or you need something, or whatever question you have, they are very helpful. You can always go to their office. If you prefer to send an email, you can always use that email so they can answer any questions that you have. Let's talk about limits. Talking about limits, well, let's talk about the first topic of one of the first topics that we see for calculus A, B, and BC, right? So let's define limits and use limit notation. Okay, so as you know, limits are pretty much the backbone of understanding that and connect algebra, geometry to the mathematics of calculus. In basic terms, a limit is just a statement that tells you what the height or the output of a function intends to reach as you get close to a specific x value, okay? Remember that in pre-calculus that you were evaluating 3 types of limits. Maybe you didn't do it in pre-calculus, so we'll go and do it here, okay? So there's one type of limit that is a right-hand limit. The right-hand limit, we're going to write it as lim. And then you have when x approaches to, and let's say that c is a number, so the right hand is going to be that, the positive side. And then you need the function f of x, okay? So verbally speaking, how you read it is the limit, okay? The limit as x, okay, approaches, okay, c, okay, from the right of the function f of x, right, of f of x, okay? The left-hand limit is going to be the limit when x approaches to c, but here you have a negative that's going to indicate the reader that you have the left-hand side limit of the function f of x. So I would say the limit of f of x, this would be nicer. That's also another way of basically interpreting this. The limit of f of x as x, okay, approaches c from the left, okay? And since you already put f of x, you know that that's going to be the left. The general limit, what we call the general limit, okay, or the overall limit, is going to be the limit when x approaches to c of f of x, okay? So this one, we say that it's the limit of the function f of x as x approaches, okay, approaches c, okay? The limit of f of x as x approaches c. Okay, so let's begin our discussion of limits by analyzing a rational function and explaining the graph. Rational functions are very common and very useful in precalculus and algebra 2. Okay, so what we're going to do here is we're going to use the equation for f of x that we have that f of x is 3x squared minus 8x minus 3 divided by x squared minus 9 of the function to analyze it completely. The great thing is I put the function here so you can see it nicely. And here I'm going to draw the asymptotes so you can see them. Okay, remember the vertical asymptote, pretty much you know that you have a vertical asymptote because you equalize the denominator to 0. Okay, then you can see that, well, and then you factored out this, okay? So let's factor. Before we do that, let's analyze why we have only one vertical asymptote, okay? So you can see that you can factor out the numerator and the denominator of this function. Okay, so in the numerator, we can factor out as 3x plus 1 times x minus 3, okay? So that's the numerator, and in the denominator, you can see that it's the difference of squares there. So you can see that this is x plus 3, x minus 3. So since we're canceling this, we know that this is going to be a whole, okay? So you know that your function in algebra 2 or precalculus, it would end up being something like this, okay? That's why we have it as if it was pretty much degree 1 or a polynomial degree 1 on the top divided by a degree 1 or polynomial degree 1 at the bottom, okay? So that's why we only have one asymptote, vertical asymptote, and the vertical asymptote that you're seeing is this one. We have an horizontal asymptote here at 3 because you can see that when you divide coefficients, okay, the degrees of the numerator and the denominator are the same, and you divide coefficients and you have that 3 divided by 1 is 3, and that's why we have that y equals 3 is your horizontal asymptote, okay? So in addition to that, you can see that the coordinate of the whole, you can immediately recognize that the whole is going to happen when x is equal to 3 because of this one that it's canceling out. Therefore, the coordinates of the whole are going to be 3, comma, and then you would replace the 3 into this function having that it's 5 over 3, okay? Because you would replace the x for the 3 having 9 plus 1 divided by 6. And then you would have that it would be 10 over 6, which you can simplify as 5 over 3 here. I didn't write everything there because I didn't have enough space, okay? So now that you can see your function here and you can draw here your whole, okay? And you know that the asymptotes are going to be -3 here, and this one is going to be y equals 3, okay? So what we do is we're going to analyze the domain, okay? So the domain of this function, you recognize that the domain is going to be based on the x-axis. Therefore, it's going to be from -infinity and then up to the asymptote here, the vertical asymptote. So you know that it's going to be up to -3. Then you have that in -3 is going to start all over again, saying that pretty much we're not including the -3 in your domain. After that, you go ahead and move up to the whole, okay, which is 3, which you know that the function doesn't have a definition at 3, and then 3 to infinity, okay? So that's going to be your domain. Remember that this is your asymptote and this is your whole. That comes from algebra 2 or precalculus, but we're going to use these concepts to understand more about the limit. The range, as you know, it's always from the bottom to the top of the function, or you are going to analyze what I say, the y-axis, okay, or the output, okay? So the range here, the problematic parts that you have, okay, so you know that this point, thanks to the whole, you do know, and I would label it here, is 3,5 over 3. So the problem that you have is this arrow is pointing down. So you start at negative infinity, and the first oopsie that you have is this one, okay, which is going to be the 5/3, which you don't have a function at that height, okay? And then union 5/3, and then you would continue, but then your function again, it's broken here at the horizontal asymptote, which is 3, okay? So you would have that it would be a 3, then union 3, okay, because it continues here, okay, up to positive infinity, okay? So this would be your range. As you can see, the range is based on the y's, the domain on the x's. As we mentioned before, for me, finding the vertical asymptote at the very beginning, and as an algebra teacher, it was very, very important, okay? So you can recognize that once you cancel this, your only option for the vertical asymptote is going to be equalizing your denominator to 0. Therefore, your vertical asymptote is going to be x equals -3, and you can see it here, okay? The horizontal asymptote, as I was telling you, you analyze the degree of the numerator and the denominator, recognizing that the degree of the top is 2 divided by degree 2 at the bottom. Therefore, since they have the same degree, you are going to divide coefficients. Since you need to divide coefficients, it would be 3/1. If you tell me where's the 1 is the coefficient of the x squared. Therefore, you know that it's going to be y equals 3, and you can see the horizontal asymptote here in action, okay? So you can see it very nicely there. How this ties down to the definition of limit. So let's go back to the same function that we have here, okay? So remember, you have your asymptotes here and here, right? And we have our superhold here, okay? So what are we going to do here, okay? So what you're going to do here is you are going to compare how and connect your pre-calculus notation to your calculus notation. Usually in pre-calculus, students learn the notation as x approaches to negative infinity, the graph of f of x approaches 3. So as x approaches, basically as x is approaching to negative infinity, right? It's going here. The graph is getting closer and closer to 3. That's what you were saying in pre-calculus. Now in calculus, what you are going to say is pretty much the limit when x approaches to negative infinity, right, of the function, in this case, f of x, is going to be equal to 3, okay? So pretty much this is going to be basically as x approaches to the c instead of the c that we had before. Similarly, here in precalculus, you have as x approaches to infinity, talking about this part of the arrow approaching to infinity. The graph of f of x, what's happening there? It's also approaching to 3, okay? So in other words, you have that the limit when x approaches to positive infinity of f of x is going to be equal to 3. So this is the calculus notation. This is the pre-calculus notation, okay? So let's go over some others. As x approaches to -3, why do we care about -3? Let's analyze it here. So this is x -3, right? It's here, okay? So what's happening there from the right, okay? So from the right, if we're moving from the right, we're moving from the right here, right? So from the right, what is going on, if you analyze, this is -3. From the right side of -3, this is going down infinitely. So the graph of f of x is going to negative infinity here, meaning that you have the limit when x approaches to -3 of f of x, okay? It's going to be equal to negative infinity, okay? As similarly, as x approaches to +3, okay? So as x approaches +3 is here, okay? From the left, okay? The graph of f of x, what's the business of the graph of f of x? You know that from the left, it's getting closer and closer to 5 over, what was it, 3, right? Okay, so 5/3, because that was your whole. Okay, so we can say that the limit when x approaches to 3 of f of x, this is going to be equal to 5/3. Okay, so that's what you have. And let me zoom out so you can see the whole thing. The thing is that my computer is on the way, so let me of my projector here, okay? So similarly here, you have that as x approaches to -3 from the left. So you are looking at, this is -3, so from the left is going to be this one. You can see that it's going to positive infinity, okay? So we go ahead and put positive infinity here. Now the translation in calculus is going to be the limit when x approaches to -3 of the function f of x, that's going to be equal to positive infinity, okay? So similarly, as x approaches to 3 from the right, okay, so let's look at 3 from the right, so from the right side, so you can see that it's going here, okay, that's from the right, okay, that's approaching to, again, 5/3, okay? So we can say that the limit when x approaches to 3 of f of x is going to be equal to 5/3, okay? So that's what we have, okay? Now, if we need to explain what the value of a limit represents in terms of the graph, we can say that the limit, okay, is the equivalent, okay, of the y value of the output, y value or the output, okay, that the graph, okay, the graph is approaching, okay, both, from, excuse me, from both the right and the left side. So from both the left, okay, side, okay, and the right side, right side of the target value, okay, of the value of x, okay, in this case, if x equals z, okay, so the limit, as you can see, FYI, okay, so the limit, okay, can occur, okay, at a hole, okay, so because f of c doesn't exist, it doesn't mean that the limit does not exist, okay, and that's going to be what we are going to call later as a removable discontinuity, but we're going to discuss that later. So informally, the limit, okay, is a y value, okay, which a function approaches as x approaches some other value, okay? So what you know is that the limit when x approaches to c of f of x is equal to this value, L, and it means that x approaches c of f of x as f of x approaches the y value, L. Okay, so this is pretty much what you learn in pre-calculus, and this is a notation that we're going to use in calculus, okay? So let's go over another topic here so you can see how simple and how fun are the limits, okay? So if you estimate the limit values from graphs, you are going to have situations like this, okay? So let's do at least 5 of this or 6, okay? So you can see how fun are the limits, okay? So consider the function shown at the right and they call it f of x, okay? Let's say that we want to find the limit when x approaches to 4 from the right side of the function f of x. So you would look at the 4, positive 4 is here, and from the right, it would be from the right side of the 4, so it would be from this side, okay? So the positive side, this one, the little hat, as I tell my students, is going to be the right side of the 4. So you can see that that limit is going to be 3, okay? If you think of the function as a highway and imagine you are traveling along the graph f of x towards x equals 4 from the right, not to the right, and you stop at the vertical line x equals 4, the y value where you stop in this situation, as we discussed a second ago, is 3. Therefore, what you have is that the limit when x approaches to 4 from the right side of f of x is equal to 3, like you see it here. So in this situation, the definition of a limit and the definition of this function, they are the same, okay? So let's use the graph above. As I was telling you, let's do 6 of this example so you can see how fun is finding limits. So this one is not a limit. This is what we were doing back in Algebra 1 and Algebra 2, right? This one is just evaluating the function at 2. Okay, so you would look at 2. then this one is the whole, so that's not defined. So the definition is going to be at -1. Okay, so you can see that this one, it would be -1. Okay, any questions about that one? Similarly, for B, what you have, this is not a limit, this is actually defining the function. So you would move to your x equals -1, and what do you see? Is this the value? No, that's a whole. Then you would go here, and you know that f of -1 here, it would be 4, right? So now let's move on from our old concepts and our old knowledge to the concept of limits. The limit when x approaches to 4 from the left side, so let's locate 4. 4 is this one, from the left side is from the left, okay? As you get closer and closer to 4, what happens to that? That one, again, is going to be 3 because you are reaching 3 as you get into 4, okay? On the other side, you have that the limit when x approaches to 2, okay? So let's locate 2. Okay, from the right side, so meaning you are seeing 2 from the right side, what happens on the right side? On the right side, it's going to be 1, okay? So the difference between basically f of 2 and this, as you can see, f of 2 here, it was -1, right? But here, the limit is different because it's as the function is approaching, okay? So that's why it's different, okay? So now you can see here in E, the limit when x approaches to 2 from the left side of f of x, meaning you look at your 2, the function is here, and from the left, you are going to reach -1. So as you can see, the limit from the right and from the left, they are not equal, okay? So that would tell you that actually the limit does not exist, and that's what we're going to see actually the first class of this course, okay? So let's do the last one, F. You can see that the limit when x approaches to -1, so you locate your -1 from the right, okay, is going to be what? It's going to be 2, okay? So, and we're going to go over more problems like this. Next week during class. Let me put the information of momentum so you can see it. I don't know if I'm sharing my screen still or not. So let me make sure that I'm sharing my screen. Please let me know if you have questions or concerns. Yes, we're going to start with limits next week. So I don't know if you have any questions, concerns. Just let me know. Remember, if you want to visit the website of the school, that's Momentum's website, or if you have questions and you prefer to talk with that person, you can always call them during their office hours to that phone number. And or if you prefer to email them for questions or whatever you have, that's the email for Momentum. And yeah, thank you so much for stopping by, and I hope to see you on Sunday next week. I'll stay here another like 2 or 3 minutes in case that you have questions. I'm here for any questions that you have, okay? So please let me know if you have questions about the class, about the format, or the platform that we're using. It's very user-friendly, the platform that we're using, in case that you are wondering.